didn't mute this one. You can't see my screen, that's why. How about now? Hey, there we go. Now you can see the screen. All right, so we got a couple things today. So we're going to get to eventually the new stuff of strings. First, we're going to talk about Project 2 with functions, and then we'll talk about the lab for iterations. Had actually several questions on doing some of those, so it's worth spending a little bit of time looking at some of those. And we'll move on to the new stuff, and then we'll talk about the next project. That sounds like a good plan. So again, this one, we're just assuming these holiday weeks don't exist, so it won't be due until 7/11. So totally up to you to how you want to plan your time. You know, if you want to get it done as if it were due on the 4th, then you have nothing to do that whole holiday week for this class, because you don't do anything else in your lives, I'm sure. This is the only thing you do. But, you know, maybe have a week off. And then on 7/11, we'll do some midterm review, and the exam will open that night. Again, it's untimed, just like the quizzes. You start at any time, come back to it any time you want. And I'll give you a practice one we can talk about, I guess, tonight. Yeah, I can put one together for you tonight. So we'll take a look at that, and then I'll go over the answers on 7/11, answer any questions you folks have. There's no plan for anything new on 7/11, so if you wanted to, you could show up, do the review, and then the exam will open at 6 p.m. You can take the exam, and you could be done for the week, if you want. It's designed so you could take it in about a 2-hour sitting. It's not meant to be super long, but I just hate timed exams, and I think the pressure of adding time limits on things makes people perform worse, weirdly enough. So we'll see. It turns out lawyers are actually, I heard, might be getting rid of their big LSAT exam, so I was pretty excited to see other people are realizing this is a dumb process. Is that a question?
Yeah, so the review is not a grade.
No, the review's not graded. I'm just going to give you a sample from, like, I don't have a last semester's exam, but I've got probably a relatively similar one I can adopt for you. So it'll be half quiz questions. So it'll be about 15 quiz questions, 1 point each. And then it'll be 3 long answer style, hey, write some code that does this. So like, one will be write a function that does something, one will be write a loop that does something, and one might be about files that does something.
Do we have to be here?
No, so it's open the whole time. I don't have to sit and watch you take it. I'll assume, because this is how things are going to go, you'll be fine. And I don't like sitting and watching people take tests anyway. So, all right, glad the sound levels are working well for you, Brian. Okay, so definitely a couple things to tackle today, but shouldn't be too bad. So let me fire up PyCharm, and we'll get moving first. Do you want to do the iteration labs first, or do you want to talk about Project 2 first? I can do either. Which one? Iterations? All right, so we can work on the lab first. All right, let me go start up a new project. New project, and this is, what lab number was that? Was that lab 4? All right. Lab 4. 4. Cool, we'll make that. All right, so 2 pieces to this one here. The while loop, right? Validating month, day, and year, or month, then day, then year. I mean, really any order was fine. This is our American format, which is the weirdest thing, because it like does the middle-sized value first, and then the small-sized value, and then the large-sized value. It's a nonsense format, so which is super weird, but that's okay. We're going to validate they're within range here, doing some validation loops, and then we're going to calculate how many days until that day. So we don't have to go crazy. Don't worry about leap years. Simple enough. Ideally, this was like a 30-minute exercise or so. Not a lot of, we didn't need to be a perfect calculation here. This was just some practice using some loops here. So if we're going to ask for some input and validate here, so we need a day. I'm going to start off at 0. We need a month. I'm going to start off at 0. We need a year. I'm going to start at 0. Because all of these will be invalid, so that my validation loop will run. Just so I don't have to prompt them and then copy the prompt in. So I can say while, and now Python's cool, we can sandwich. So I can say 1 less than or equal to day less than or equal to 31, if you wanted. Python lets you do this. If you wanted to, you could also write it in a more traditional while day is greater than or equal to 1 and day is less than or equal to 31. Both of those are perfectly fine. I prefer this syntax actually because like I like how it looks, like kind of sandwiching it between the values. It's okay either way, no big deal here. I'll leave that commented. And while day is valid, oh well, that's not what we want, right? We want this while it's invalid. So I guess we can't technically sandwich here because this means a valid day. So we could put all of this then in parentheses if we wanted and say not. Remember, not is the opposite. It flips it around. So it'll take a false and make it true. It'll make it take a true and make it false. That's an option. Or we could go back to one of these here. So really, like, this doesn't work here. We could do one that does work and say while day is less than 1 or day is greater than 31. Right? Either invalid range, this invalid this way or invalid this way. Either side of invalid, the whole thing will be invalid. We can run. Or take what the valid range is and say not valid. Right? Tons of different ways of going about these here. I don't really know which way I prefer. I kind of like this one here just because like we see what the valid range is. I don't know. Maybe, I feel like this is slightly easier to read than this, but ever so slightly. Anyway, so if it's not valid here, then we'll prompt them for day. So we'll say day equals an int of an input. Input. Enter the day of the month. Like 1 to 31. Right? Sure. We'll get the day. That's it. If you wanted a nice message, you could say that was invalid, try again. Sure. We don't, don't really need another message like that. And this, if it's not valid, it will keep on going. And yeah, it doesn't like my spaces. Right? Same idea for month then. We'll say, well, it's not less than or equal to 12. Enter the day of, or the month. 1 to 12. And then same for year. So now this was 2023, I think we said, right? 2023 to 2029. Sure. 2099. There we go. So that was for year. Enter the year. Oh, and this needs to be month here. And this needs to be year here. So a couple prompts doing some validation loops here. Again, any of these syntaxes, right, as long as it does work, right? This one doesn't, unfortunately, but that's okay. Like anything that does work was great here. Now, again, these really have to be while loops. You can't have a for loop that does validation because there's nothing to iterate over. So there's not like 10 times and then we give up on you, which actually might be nice. Like if you've entered it invalid 10 times, we probably just eat your ATM card. Maybe that might be a for loop. But again, for our purposes, like as long as you're giving us something invalid, we'll just keep asking you. And hopefully you'll figure out one of these times we give you the right value. So day of the month, enter the year. Oh, that's we need the right range here. So 2023 to 2099. Again, giving the information is nice because that way they know what they should be entering. Then we need to count. So this was days until that date, right? Calculate how many days until that day. So this is days until the date. I'm going to start off at 0 here. Then we have to do some math. Again, not super crazy math. Like don't necessarily need to count every specific month. Don't worry about February being 28. If you wanted to say it was 30.5 days for a month, that was probably fine. Or you can count every other one as 30 or 31. Lots of different ways we could do that here. But let's do the day first, right? Because I want to see what today is. And if we're less than, right, we can count forward and then add a month. Right, until we meet the right day, and then we just need to count by months until we hit the current month. I think might be the easy approach here. So we'll see how it goes. Again, probably could do it in any order, but I think this will work out nice. So we'll say, now it probably could be arithmetic if you don't want to do loops. Right, the calculation here is not too bad for that. If you wanted to do a loop, you could do a loop too. It might be a little slower, but loops, might be fun for that. So we could say for how about date, I don't know, date in range day. We could range up to the day we wanted to go find, but then we need to compare it to today's date, and that can be a little tricky. So again, the loop here might not be super great. Maybe we just want to start with, hey, if day is less than, and then I'm going to make these like some constant values so they look a little prettier here. We say today's day is 20. I think you would have probably had 13 last week, right? And today's month is 6, and how about today's year 2020, 2022? Yeah, that's hard to say. There's a typo? I know there is, but what do you... I can't put an apostrophe here. Like, what does it want for my typo? That's silly. So if day is less than today's day, right? Well, then we can count ahead till we get there, right? And then increase the month if we wanted to. That gets a little funny too, I guess. If I guess we're not December, so no big deal here. This ought to work easy because it's not December. So if the day is less than today's day, right, then we need to work ahead. Well, what does that end up being, right? If we need to count up into the next one here. So really, we should be able to subtract the difference, I think. So we take day minus today's, today's date, today's day minus the day. So like if I put in the 13th, 13 is less than 20. 20 minus 13 should be 7. 7 days past when we wanted to go. Can we do that and figure it out that way? So how about days until date equals today's day minus the day? That'd give us a negative number, but that's like counting backwards on our clock. Would be okay, right? Because then we're going to count months and we'll go forward positive. Probably okay. And if it's not, well, really, we can do the same thing, right? If we said, hey, how about day was 30 and today's 20, we still get 20. 20 minus 30 is not going to work because we want that one to be positive. All right, so negative is okay. And then how about else then? We'll just flip it around. We'll take the day minus today's day. Right, so if the target day is before ours, we'll go back 7 days. If the target date's after ours, we'll take that date minus ours. So if we said the 27th, that'd be 27 minus 20 would give me 7, positive 7. Okay, and then we can start counting months. Can we do that? Now, for counting months, then, we need to see if we're ahead or behind. Right, so this time we're definitely going to have to change the year value if we're counting ahead versus if we're behind, we could just count forward. So if month is less than today's month, then we need to count that many months ahead until we get back to here. So if we put in 5, right? So then we have months, I don't know, that's today's month minus month, and take 12 minus that. Does that work? I think that works. So if today's month is 6, and you put in May, we get 6 minus 5 is 1. 12 minus 1 is 11. You have to go forward 11 months to get to the next month. I think that works. And then otherwise, right, our else case here then, oops, here's my parenthesis. Again, this part of the arithmetic's not all that important here. It's just, we can do some, we can kind of puzzle it out here. Then our months then is going to be, what, the month minus today's month, right? So if you wanted July, 7 minus 6, 8 minus 6, right, that'll be the number of months we need. So either way, we get a value for months. And then days until date here then is going to, we'll add to it months times 30.5 on average or so. Right, can we do that? And then if we want it to be fancy, we could maybe make that an integer. Right? So round it. We'll drop the decimal, which is okay. This is a close estimate here, right? It didn't need to be perfect. If you did something fancier where you actually got perfect, that's even better. But again, probably harder than we needed to do. You with me so far? 31 minus today plus the target. What is that for the days? Oh, we didn't do the days here, so we need. Oh yeah, so no, we're starting here. So if we did 31 minus today plus the target, would that work? Maybe? I don't. Okay, that's an old comment, sorry. So now we have the correct number until the months here, but then if we were less than today's month, we needed to take our year plus 1. right? Because we've moved into the next year. We counted 11 months up until May, so now year needs to move up, right? Then we can take our days until date here, and we can add to it 365 times the year minus today's year. Oh no, we should subtract one from year. What should we do for this? We should subtract one from year, right? So move the target back down one. Or we could add one to today's year, but it's marked as like a constant, so we probably shouldn't change it. I think this probably works out better. Right, so 365 days for every year then we need to get to. Probably good. And if you wanted to do leap year estimations, like every 4 years you could go add one, but then whether or not we started on a leap year, that's okay. Dates are hard. And we'll print days until date. Days until your date. Approximate. Approximately. There we go. Should we try it? Okay, so what day of the month?
February.
February. No, sorry, day. The 15th of February? What year? 2050? About 10,000 days? Okay, let's just go Google that. So that's February 15th. Days until February 15th, 2050. 10,102 days. 100, look at that. We were pretty close. That's not too bad going out a bunch of days here, right? It's impressive. I think we're overcounting at 30 and a half because February means we technically have a little bit less. I don't know. That's okay. That was pretty close. I like that. Should we try it again? Let's make sure our validation loops work, right? Like 100. No, a day of the month. 1,000. Nope. 0. Nope. Right, so our validation loop works. That was mainly the point of this. 15th of June 2023. 370 days. Uh-oh.
Did you
I think we're backwards.
each month was different number of days?
We said 30 and a half was our estimate here.
Oh.
Just to be a cheap, easy estimate here. We could have done something fancier and like loop through and then added the right number. That's a lot more work than we probably wanted to do.
I just did a lookup.
Yeah, no, you could do that. It's not too bad to find the right value. Yeah, if it's 30 or 31. Yeah. We haven't got to arrays or anything yet, so it probably would just be a big if else.
Yeah, I did both.
Okay. Hey, Crow, thanks for coming on by, my friend. So, we're pretty close. I think something's wrong with this, right? Because that should have been minus. Right, so we had 15 is less than 20. So if day was less than today's date, we should have had today's day minus the day. Oh no, this is backwards. Do we still want day minus today's date? I think we still do the same thing. Right, because this would end up with a positive value. We don't want positive. We want it to be negative. So it's just day minus today's day. And if that's the same thing either way, it just works, right? Because if it's negative, that's okay. If it's positive, that's okay too. Because we're counting the months regardless here, I think is why. Hopefully that'll work out. Let's try it again. So we do 15 of 6, 20, 23. Okay, that's a lot better, 360. Right, so if we do the 20th of June, 2023, 365, right on the nose. It's pretty good. Again, the arithmetic part wasn't super important here. It's like practicing these validation loops, which can be fun. Right, figuring out what is the right way to say it is invalid. You need to keep on going here. We all right with that one? And then our next loop, these display all the possible hour, minute, seconds here, like all the way on through. If you want to do the 24-hour clock, cool. So we just need to do some loops. We'll say for hour in range 24. Remember, range will get up to, but not including that last value. So I'll get 0 to 23 here. This is 0 to 23. And then we'll say for minute in range 60, will get me 0 to 59. And then for second in range 60, we get 0 to 59. Oh, 59 here, right? Again. Oops, I need some colons here. There we go. Colon, colon, colon. And then we'll print hour, minute, second. And if you wanted to add in some colons here to make it look pretty, that's probably better. And it's not going to be perfect. We haven't talked about formatting. We're going to get to that this week to make this formatting look a lot nicer here. Because we'll have some funny spaces. 1, 2022, 2023, sure. So if there's like one-digit numbers, they don't print out with the extra zeros, and that's okay. Not too big of a deal here. We haven't figured out how to do that yet. But this will show me all the possible values here. So you can loop inside of a loop, 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 like as far as you want to go. At some point, that's pretty crazy, because we're going to be like tabbed in halfway across the screen, and we won't really know what's going on here. So I'm going to put my phone on quiet here. Oh, I got a new phone this weekend, and it's the worst thing to have to sign into every single app over and over and over and over again. I don't think I only had to reset one password though, which was pretty cool. I think the single sign-on stuff is nice, but all right. So we've got all of our loops. We okay so far with the lab? Make sense? All right, so let me commit that here. Let me pull up our repo. So this is 2131. Here's lab 4. Commit and push. All right, then we'll start up a new project. This was project 2 we're going to talk about now. Project 2 was all of our functions. Let me go back to assignments here. And our functions. So building out a couple functions to do a couple things of a badly adopted tabletop role-playing game character creation tool. So we'll have a function getName. This one specifically will ask the user to enter their name and return the result. Not very interesting here, but we're just putting a name to what we're doing. So we can kind of see, hey, this is what I'm going to do to make my character, right? We put a name to it. We don't really gain a whole lot out of it, but that's okay. So let's kind of write this out here. So we'll say name equals getName, right? And then strength equals, and then what are we going to call this one? Sum of a 6-sided die with lowest dropped. I know it's a mouthful, but that's literally what we're doing here for this. I think I've zoomed in too far then. Yeah, that's a little large. There we go. Strength equals that. Dexterity equals that. And, oh my goodness. Constitution equals that. Oh, constitution. There we go. Equals that. Intelligence equals that one again. Wisdom equals that one again. And charisma equals that one again. Right, we'll go get some values out here. Okay, not so bad so far. We'll go write those functions in a minute here. And then get ability modifier accepts the value for the ability score, returns our modifier you see in the table here. Someone pointed out there is also some math for it. If you actually looked at the bottom of the table, it showed you the math. If you didn't want to do a bunch of if-elses, you saw the math. Great. If you just did a bunch of if-elses, that's cool too. That would totally work. So then that's just a function. We're not using that one yet. And then our function for menu prompts the user to enter their action, returns their choice. They can pick from one of these. It didn't have to be a validation loop because we hadn't gotten to that yet, but it might be nice if it was a validation loop. So I'll build it out like that. Again, you weren't required to at all, but you can see how that would work here. And then what the different actions do. So we got an attack action, we got a negotiate action, we got a search action, we have an eat action. And then they'll do it for 4 times, display the result each time, and we'll go. So maybe we'll have something like for, I don't know, round in range 4. We'll get a choice is the menu, and then if choice equals attack, maybe we'll do the attack thing, right? Else if the choice is equal to negotiate, then we'll do the negotiate thing, else if the choice is equal to, was it search? We'll do the search thing, and else if the choice is equal to eat, we'll do the eat thing. Right? You do some of those if we wanted. And we might need to fix these up as we go, but sort of just kind of fleshing out the steps of what's going to happen here before we write any functions. Right? We know, okay, we'll do something here, we'll do something here, we'll do something here, we'll do some things here, but this is essentially all we have to do. Okay, now we can go and write the function. So we can define a getName function. So getName, then just, you can have name is, right, and say an input, enter your character's name. Character's name. And we can return name. Sure, we'll return name. Great, that one's done. Some of these 4 6-sided dice with the lowest dropped. Here. So we need to get 4 random numbers and drop the lowest one. Right? Okay, so we'll take a sum. We'll start off at random.randint 1 to 6. We probably don't want to start at that. So how about die 1 is that? And then how about die 2 is that again? Die 3 is that one again. And die 4 is that one again. Right? Then we'll sum them all together and drop the lowest one. So sum will equal die 1 plus die 2 plus die 3 plus die 4. And then we can subtract from sum the lowest. Now, if you did the reading in the online textbook, you'll know the min function that would return the minimum here can return the minimum of more than 1. So I can put in die 1, die 2, die 3, die 4, and it will give me the smallest one of those here, subtract it from the sum, and we can return the sum. If you didn't look that up, that's okay. If you didn't notice it, it's okay. You could do it the hard way and say, okay, die 1's probably the smallest. Is die 2 smaller than die 1? Great, we have a new smallest. Okay, is die 3 smaller than the smallest? No, okay. Is die 4 smaller than the smallest? Sure. Okay, we have a new smallest, right? Just compare the one at a time or do the min one at a time as we roll them. Any way is going to work here, right? It's okay. No big deal here. This was one of those funny things you can do with functions where it can take multiple values, which is kind of crazy. But that was some of the additional reading that we were just going to leave for later. Okay so far? Okay. So now we'll get the sum of 4 6-sided dice with the lowest dropped. So we get the name, we get the values. For the round, we have to do some things. All right, menu then. Let's do menu. Find menu. And this will be, I don't know, how about we print you want to do, and then maybe we just kind of print out a menu here. We could say 1 is attack, or I guess we don't even really need to do any of that, right? We can just give them different values. You could do menus with numeric values or character values. Either was probably okay. Attack, print, negotiate. That one's going to be fun for people to spell. Search and eat. Here, I will print those different options, and then we'll have their choice is equal to an input. Now remember, inputs, you don't have to give something, right? If you want to just print out some values first, then do an input. The reason I don't like putting all of these in is I'd have to do my own new line characters. Right? You could put it all in here, but then you have to do those \n's, and that just looks ugly to me, and I'm not a fan of that. So maybe this is easier, maybe not easier. It's okay. You got a couple choices. And then we wanted to do this as a validation loop, right? So how about we say choice is equal to an empty string, and then while choice does not equal attack, and choice does not equal negotiate, right? And choice does not equal search. Let me bump, see, I think I can bump that down a line. Nope, I need that slash. Sometimes PyCharm does it for you, and sometimes it doesn't. I still haven't figured out why. It does not equal eat. Excuse me. That needs to be tabbed in one more to make it happy. So if it's not attack, and it's not negotiate, and it's not search, and it's not eat. So if we and all of these together here, this is saying it is not a valid choice, and it's not a valid choice, and it's not a valid choice, and it's not a valid choice. If any one of these is false, remember when we and together, any false makes the whole thing false when we're anding. So if any of them is a valid choice, then the while loop will be false, and it will stop running. So we can do these loops here with menus. Once we get to lists, I'll show you an easier way to do this, but we haven't got there yet, so we're just doing it one at a time here. And again, it was only 4 items. It's not too bad. Even if we add up like 15 items, it's not the worst thing in the world to have a bunch of and nots, but it'll be okay. I'll say choice is the input here. Eventually we'll get the right one, and then we can return a choice that is valid. Remember, we didn't need to do the validation loop. This was just extra. Validation loop was extra for fun. Just to, again, practice some of those validation loops. They're super handy when we're dealing with inputs here. Okay, so now we have the menu. Then we need to see, okay, what are we doing here? Now, attack, right, what we need to do is take the better ability modifier score for strength or dexterity. We need to know which one's better. So we could either figure out which one's better first and then give it to attack, or give attack 2 values and let it figure out which one's better. Either way is okay, depending on however you wanted to break that up. I'm sorry? We haven't done that random yet. We'll get to that in a second. But like for what it's going to need to know, it needs to know a value here, and then it will go pick a random number like inside of attack. So we can probably give it the, so we need that get ability modifier score, right? So we need that other function, get ability modifier for a score. Now this one here is finally taking a value, an argument. So you'll tell the function what the score is. Given that score, it'll give you what the modifier is. And remember that modifier was going to be the score minus 10 floor divided by 2, I want to say. Right, so if it's 10, it's 0. If it's 11, it's 0. If it's 9, it's minus 1. I think negative 1 floor divided by 2. Oh, does that give me 0? Maybe it gives me 0. Maybe we need to round down. I don't know, let's go look at the table here. So it had this little table here, and then, oh yeah, rounded down. So not, so integer division doesn't work well for our negative values, because negative 0.5 rounded down is 0. Or no, rounded down should be negative 1 when we round down, but floor division will give me 0. So I think we want to definitely round here. So we'll do divided by 2, and then we'll do math dot floor. Floor is to round down. We got to import math. Import math. There we go. So we'll take the rounded down score of that here. Again, if you did a table, that's okay too. You could have like say if it's 3, return minus 4. If it's 4 or 5, return minus 3. Yeah.
I thought that's where I had a little bit of issue. The modifier, I thought the table was from 3 to 18.
So our valid values could only be 3 to 18. This table's larger because in the actual game you can get a wider range of values. For what we said is it can only be 3 to 18.
Because I made it where it could go from negative 5 to 10.
Okay.
Or 3 to 15.
For your scores?
The scalar.
So okay.
The scalar would be negative 5, and then it starts at negative 5, and then you add 1 for 2 and 3, and then you add 2.
Okay, that'll be okay. The arithmetic here is not that important.
On the other one, I have the capability of my scale went from 3 to 18 for the modifier.
Oh, okay. That's okay. The arithmetic's not the biggest deal.
All you have to do is actually, instead of like change the code, you just put in not 3 but a negative 5, and it would use that table.
Oh, okay. So you can take a different scale essentially.
Yeah.
Yeah. Okay.
I
that's cool.
2 scales because I didn't know.
Oh, I'm sorry. Yeah. Sorry you did the extra work, but yeah, that's no big deal there. That should work out. So we'll get the ability modifier. So for attack, then we need the better of strength or dexterity here. So if we wanted to, we could take the max of the get ability modifier for strength and the max of get ability modifier for dexterity. Right? I give both of those things to max. I'll get the larger value and I'll hand it to attack. One approach, right? Or if you wanted to do it on more than one line, right? The better modifier, right? Is that a little cleaner maybe? Always happy to add more variables here if that makes things cleaner. So the better modifier then, I think I'm missing a parenthesis here for max. Yeah, missing a parenthesis for max. Right, so we'll see which one is higher. Maybe we'll bump that down. And then we'll give that to attack. Negotiate then, we said was going to be the charisma score. Sure. So that's simply the get ability modifier for charisma. For search, that was going to be the better of intelligence or wisdom. So we'll do that same idea here. We'll take a better modifier for search. And then we'll do this for intelligence and for wisdom. And then we'll give search the better modifier. And then for eat, we just need to give it the ability modifier for constitution. Again, we don't have the functions yet, but now we've given it what values we need, right? Because it needs to know those better modifiers, whatever they are here. Okay, now we can go do those things. So we'll define the attack function. wants one extra line here. So we define attack given the modifier, attack modifier here. So if you tell me what your modifier is, I'll figure this out. So we'll say, okay, roll the 20-sided die, add their modifier score, then we'll see if it's greater than 12, we'll do something. So if random.rand int from 1 to 20 plus the modifier is greater than or equal to, what do we say, I think 12? 12, that's a hit. And again, this 12 here is a little bit ugly, so maybe we wanted to add in something up here, like this is the minimum, I don't know, roll to hit, if you wanted to. Again, not necessary, but I'm a fan of putting names to these magic numbers, essentially. Otherwise, you're going to be like, well, why was it 12? And have to go back and figure it out here. So if it was 12, then we hit. Roll a 6-sided die, add their ability modifier, calculate the total damage, display the result. Not going below 0. So like you can't do negative, because if you roll a 6-sided die and get like a 1, and your better modifier is still a negative, it'd be 0 or less, right? So a couple other checks here then. So our damage then is going to be my rand int 1 to 6 plus the modifier, and then if damage is less than 0, we'll set damage back to 0, and then we'll print you hit and deal damage, right? Else you miss. Okay, that's what happens when we attack. If we choose negotiate, roll a 20-sided die. If it's greater than or equal to 15, they successfully negotiated the truce. Sure. So we'll define negotiate, given the modifier. So again, our random number here, plus the modifier. How about the minimum roll to negotiate? Here. So we would go up, add another variable. 15, sure. So if it was, then we'll print you negotiate truce. Otherwise, print they still, I don't know, or they still want to attack you. Sure. Whatever. It's, you know, the opposite of getting a truce here. Okay. Then we'll do our search. Define search. Again, given a modifier. So if yours had both scores and then it figured out which one was better inside of here, that's perfectly fine. Right? There's no hard and fast rule saying it had to just take the score here. Right? You're welcome to pass the other values and have it figure it out here. Either way is up to you. I sort of like how this reads. Again, we don't even really need to look at the functions. We can just say, okay, this is what the name of the function is, what's happening here. It's just kind of nice and clear to see here. We can also go look at the functions. Search, okay. So we need to roll a 20-sided die, add our better modifier. If it's greater than or equal to 12, they found some treasure. Sure. So again, essentially right here, we found some treasure. Minimum needed to find treasure. We add another value. That one's 12 too. I mean, and the nice thing here is that they're easy to tweak because we just come up to the top and we can change these values. And like just change it one place here for, okay, maybe we want to make it harder to find treasure. Like as we're actually trying to balance a game, it's easier to tweak one place here than to like have to go find it inside of all your functions. All right, so we found some treasure. Then otherwise, if they find treasure, use a function that returns the name of some random treasure. So a function calls a function. Okay, so we will print get random treasure name. Treasure name. So we need another function. Define get random treasure name. So pick a random number here. So how about we say if, I guess we need a value, equals a rand int 1 to 6. We'll just do 6 different treasures. And if value is equal to 1, then we're going to return gems. Right? So these could be else ifs, but the else at that point is redundant. If you hit return, you're done. So a lot of times you'll just see value here, right? Or another if. If it equals 2, we'll return jade statue. Sure. And then if value is equal to 3, we'll return gold if value is equal to 4, we'll return, I don't know, what other, does I have other suggestions here? Other type of treasure. Right? If value is equal to 5, I could just do 1 to 4, right? Did it specify 1 to 6? Yeah, just some random treasure, sure. There we go. There's 1 to 4. Now, this problem is we can't have an else default here, right? I could have an else at the very end if I wanted, and if it's not 1, if it's not 2, if it's not 3, oops, if it's not 4, you could, or we could just have a return, you know, if it's not a 1 to 4 here, it'll just hit the return statement. Doesn't really need to be an else there. Just however you want to kind of lay that out here. Yeah, Professor Burke, go for it. Update your self-assessment, no problem there. Return, I don't know, what other kind of treasure? You found a laptop. Sure, I don't know. So we'll get the treasure. So when we're searching then, right, we can get random treasure name and print it out. Or you find a, get random treasure name. Oops, this should just say laptop. And this is just the name of the treasure. The a or an is here, our pluralizing stuff is hard. It's okay, don't worry too much about it. Okay, so we got our functions. Now we still need eat. Okay, so we'll define our eat function. Define eat, give it a modifier. Okay, and this one was going to be their food was rancid. Okay, they had to get a 10 or more here. Sure. So we'll check and see. Minimum roll to not get sick. Sure. When eating rancid food, I don't know how long you need to get this here. That's okay. Equals 10. So roll the 120, add your modifier to not get sick, and then we'll tell them you're able to eat the rancid food without getting sick, otherwise they get sick and need to stay in bed. So, and you ate some rancid food. Maybe this happens anyway, right? And then, but shrugged it off. I don't know. Are okay. Otherwise, print and got sick. You need to stay in bed. I don't know. Anyway, you wanted to do that. Not too big of a deal here. Oops. Where's my? Enter down one more. All right. And then we let them do this 4 times. Right. We'll get their choice. If it's one of these things, we'll do that thing for every round. Now we never used round. Well, that's okay. Oh, it's saying there's a round function. That's okay. Built-in name for round. That's okay. How about turn then? Turn. For turn in range 4. We'll get 4 turns. We'll go do these things. That makes sense so far? Should we try it? Do we need to use name in any of these? Returns result. I guess we're not really using name here at all. Sure.
It's like you have to use it somewhere else.
Is it? Okay, let's see. In the rubric. Oh, and the name is used in the outputs. Okay, so if we need name, then we can pass name to these functions here. So or they could take other results here. So we'll take tac, and you also then can pass in name. So instead of you, then we'll say name hits and deals damage, or name misses. Okay, and pass in name, and we get name.
So
negotiates a truce. Yeah.
I have a question. So what I did is I did a print, and then I took all the modifiers, and then I used print the name each time they did attack.
Okay.
The first line was the name, and
sure.
all the sword.
Okay. Yeah, giving them more details.
I did make one mistake that initially I had. The other question was if you have the strength in the other modifier, if you're always choosing between which one's stronger, then there's no real randomness to it.
Well, the values are set randomly.
In there, and then what I did, I instead of picking not the random, but
when you go and use them in these.
between the strength and when you do an attack.
Yeah.
I didn't use the max. I used the random between 1 and 2.
And just picked one.
Yeah.
Okay. Oh,
Because that makes it more random. Because initially the attack was always just getting. He could.
Well, it still should be based off of the random 1 to 20 score.
1 to 20.
So even if
Then
you've got a
you
good
really have
modifier.
two things that are gonna be like strong.
Yeah. So
you
ideally,
use,
it's
like-
you're using your best to your advantage. Like you want your players to hit and to be successful.
Initially had that.
Yeah.
And then I
That's
took it
okay.
off,
Yeah, that's fine.
But yeah, you can knock me down.
No, it's okay. It's
No,
happy to modify these
I
things.
consider-
Yeah, name didn't find anything, and then one more name. Name ate some food. Ate some rancid food. Okay, I think we got all those. So now we need to also then give it name here. Name. Negotiate is name. Search given name. And eat given name. Okay, thank you. I'm sorry that was in the rubric, but not the description. That's we definitely want to go off the rubric here because that's where I click the buttons. Ability scores get generated. Ability modifiers. Function prompts the user returns their choice. Attack, negotiate, search, eat options. 4 choices, then end. So I think we got all the things in the rubric. Let's actually see if it runs now. Right. All right. What's our character's name?
Killer.
Bob. And what do you want to do, Bob? Bob is going to attack. Bob hits and deals 10 damage. Woo! That's a good roll. What do you want to do, Bob?
I suppose it should try to negotiate.
Negotiate? You failed to negotiate. You're strong, but must not have very much charisma. All right, should we search?
Sure.
We find another type of treasure. What do you want to do? Let's eat. We ate some ransom food, but are okay. All right. Now, if we wanted to clean that up a little bit here on our eat here, print, I think we saw, I don't remember if it showed you or not, you can change the ending character so it doesn't go down a new line. Does that ring any bells? I think it was in the textbook somewhere, but I've never shown it because it's silly. But if you want to, you can say, hey, the end is equal to something else. So by default, so print has an ending argument that you can give it. The default for end is a new line character. So it prints the thing you give it, and then we'll add a new line. If you don't want it to do that, we can say, hey, end with a space instead. So when it says Bob ate some rancid food, it doesn't go down to the next line. This will print out starting at that same place. And then this print will end with the normal default ending character, which is a new line. So you can kind of like sandwich things on the same line with multiple print statements if you change the ending character. Or you can put anything you want in here, like you put a bunch of like any characters you want here. But commonly, we would change it here to something else, like that one. So now if I said eat, oops, my character's name is eat. Oops, eat ate some ransom food, but they're okay. It just ends up on one line here. So like, here's that space character that we ended with instead, and then we just kept on going when we print the next one. Hey, glad to have you along, jokester. If you do want to start back from the beginning, go ahead and check out YouTube. All right, questions, thoughts, concerns? Again, this is not the only approach, right? Programming is probably more of an art than it is a science. There's definitely a lot of science and correctness that goes into it here, but the art of how do we design these things, how do we lay them out, how do we name them, how do we organize them, that's all art. So I'd like to imagine contemporary art doesn't count as art, but people pay millions of dollars to the contrary of my belief that contemporary art doesn't qualify as art. And sure, go for it. Why not? So we can call this one art too. Okay. All right, let me go ahead and commit this here then. This is project 2. Commit and push. All right, awesome. Hey, thanks so much for following along and subscribing. All right, do you want a break before we move on to new stuff then? We're just about at, not quite at 7, but usually break around 7 or so before we start new stuff, or we can start some new stuff and then break in a couple minutes. First person to vote wins.
Break.
Break. All right, someone voted for break. So let's take a 10-minute break. Let me throw some music on, and then we'll come back and pick up strings in the new stuff. Okay? And don't forget, we have the new project coming up this week as well. We'll talk about that one. And then I'll have the sample midterm for you. So we got a couple things. We're not going to go over the sample midterm yet. We've got all next week to do that. Is that already next week? No. Next week is files, right? I'm backwards here. Let me double check. This is why it's all written down, because I cannot keep these things in my head. I think we have files first. So next week I'll have the sample midterm for you, right? Yeah. Next week we'll have files, and I'll give you the sample midterm so you can take a look at it before the review on the 11th if you want. Okay. There we go. I was losing a whole other week here too.
So the midterm's on the 11th.
So it will open on the 11th. It'll be due 6 p.m. by 7:18. It'll be like the chapter quizzes. You can start it, close it, open it, come back to it anytime you want. There's no timer on it other than the due date.
There was one question on the quiz, but maybe you can, it was about for loop objects.
Mhm.
Didn't really cover that. I didn't know if I got that.
Let's take a look. So it should have been out of the text then, this last chapter 5 quiz. Let's see. Oh, it's actually not due till 11:59 p.m. So why don't I talk to you
Okay.
after the due date, or I can just talk to you about it if you already submitted. Is that okay? Because I think we got a couple more people that still need to turn that one in. Okay. All right, no, not too big of a deal. And the lowest one does get dropped, so and they're only worth a little bit of your overall score there. All right, so let's put a break on. That puts us at 7:03. All right, see you folks in a little bit. Alrighty, I think we're back.
Oh, yeah.
So we've got new stuff going on. Let me double check here. Trying to remember what I called these ones here. Project 1. Oh my goodness. CIS 2131. Let me find it. I don't remember if I was naming these by week or by chapter. By week. Okay, so let me make a new project here for week 5. Is this only week 5? This is really like how we're counting week. Oh, because we missed a week for Memorial Day, right? So all my other classes are week 6. I was really concerned. So this is. Do we not? I guess we didn't have one. 1, 2, 3, 4, 5. Sure. Week 5. Do I not have a week 5? Yeah. I had chapter 5. Okay, I was naming them wrong. That should have been named differently here. So this is week 6. Okay. I'm going crazy, friends. I'm going crazy. Let me go rename that here, because that's going to bother me. Let me do show and explorer here. So chapter 5 would have been week 5, right? Let's try and keep this straight here. So let's rename this to week 5. Now, the GitHub tool is actually pretty smart. It's going to say, oh, I didn't show renames. Usually it notices if it's a rename, but that's okay. So here's rename 5 to week 5. There. Hopefully that'll keep things straight for you. All right, and back to the new stuff. So this is all about strings. So we've done some strings before, right? Like name is Eric Chernesky, and then you could print name or do all sorts of fun things with name. We've done a couple, right? We did like name.lower or name.upper when we were comparing strings, because anytime you're getting user input, you don't know what they're typing in. So taking it either to lowercase or uppercase makes comparing it a little bit easier for you. We could do something like that. My name looks weird at both upper and lowercase. That's just kind of fun. But some fun things you can do. So we don't generally, because we're using PyCharm, we're not following along in the idle environment that Dr. Chuck uses. But when you install Python, you probably got this little idle thing here. This is a REPL environment, so you can just start typing Python and it will do Python for you. The problem is it doesn't really save very well. So like I could say, hey, like name is Eric, and then I could print name. And that's why like in his examples, he always has these triple arrows. That's like the prompt line, and then they have results that come out here. Now this one doesn't even zoom in very well here. But if you say a dir of name, dir is a listing of all of the things you can do with name here, and it'll show you that in the textbook. So all of the different methods that we can do. Now this is useful if you're in this sort of environment. For us, because we have PyCharm, I hit name dot and I get the list of things we can do with it. So you'll see his examples kind of following along a more simple environment, which is fine, but I'm a huge fan of IDEs and tools that let us do stuff like this, like PyCharm. Right, so now you can see, okay, here's all the things I can do with it here. So is numeric will tell me whether or not the string value here is numeric. Is it a space? Is it a title? Is it upper? You can left justify it for a given width. You can left strip this here. All sorts of fun things you can do with strings. It's actually probably more than we ever knew we could do. So what you want to do, he's got a little list here. Where did it go? This Python help. So docs.python.org/3 is for version 3. And then we can find in all of their documentation here cool stuff about Python library things. This is all the things you can do with strings. So you can capitalize it. Make the first character capitalized and the rest lowercase. That's fun. Case fold. Okay, kind of like lowercasing, but remove all case distinctions. Huh. I have no idea what this German lowercase letter that is an SS is here, but that sounds neat. Sure. Why not? You can count the number of times something appears, a given substring appears. You can end with, see if it ends with a given something or other. Extend tabs. Sure, tabs get replaced by spaces. There's like all sorts of crazy things we can do with strings in here that you never really knew if you wanted to. Is title if it's title cased. So uppercase characters may only follow uncased characters, and lowercase characters only cased ones. So uncased characters are things that you can't uppercase, right? Like an underscore or a space, right? Special characters can't be cased. This is like figuring out if a word is title cased would be really hard without this built-in function. Like I'm already having a headache thinking about how to do this sort of thing here, right? If it's uppercase or not, lowercase it. Join is really fun. We haven't really done a whole lot with that. We'll get to that if we talk about lists next couple weeks. We still have files to get to. All sorts of fun. Replace. You can replace a given something with something else. Is pretty handy. Let's see what other fun ones. Split is pretty common. That's a pretty fun one here. And we'll take a look at those. And let's see. Starts with, if it starts with something, it's nice. You can title case it yourself, right? And go back to every character that's not following a caseable, whatever that nonsense is here for that. Sure. So there's some built-in ones. So all sorts of cool things. Again, I like that we can just hit dot and you get some suggestions of things that you might want to do with it here, right? So if you wanted to like replace here, it says, okay, let's replace, well, what do we want to replace? So how about we replace every, how about an E with, what do we want to replace it with? How about an X? Just for fun, we'll make this look really silly. Now, name.replace here is not going to change name, right? Doesn't actually do anything here because strings are immutable in Python. That's our fancy term for they can't change. So what this actually does is it makes a new string. So replace will return a value, which is the new version of the string. It can't change name. So if I wanted to, I could say name equals name.replace. And then Python's going to go out in memory and tell the operating system, hey, I need a place for a new string, and the name will point to that new string. It'll say, hey, this string's over here in memory, in a new place in memory. Then it's effectively saved it here. We replace the lowercase e with an X. Sure, why not? So if we wanted to be silly, we could take a name here and replace all the vowels with X. A, E, I, O, and U. And probably we want the lowercase version of it here. So let's get name equals name.lower first. So we'll lowercase it here. And then how we print it as title case. So we're lowercase it all, so the replaces are easy, because replace, again, only matches exact characters. I don't want to have to replace uppercase and lowercase if we don't want to. Now we get, all right, so Xrick Cherksnitsky, I don't know. That's a mouthful there. But we can replace. So you can do some fun things with strings here. Now, you might want to ask someone like what their email address is, right? So we'll get an email. Here is an input of enter your email. And then we can check to see if email.ends with a, how about .com, right? If it ends with .com, great, we'll say it's okay. Or maybe if it does not end with .com, not ends with .com, print, is that really an email address? Now I know like some other people have .net addresses or other things like that, but I think by and large they're mostly .coms now. So this is not good email validation here, not good validation. But you know that's okay. We're getting there. Okay, we'll be suspicious of it here. So enter your email like ethr1@oaklandcc.edu. Is that real? Uh-oh. Okay, so .com or ends with .edu. I don't know. We can throw in the .net too, just throw a bone for those people. Or email.ends with .net. So if any of those is true, oops, too many parentheses there. We're good, and not true. So only if all of them are false. If it's not this, and not this, and not this, then we should really be asking him here. So let's try it again. etr1 at oaklandcc.edu. Great, we didn't worry us at all here. And maybe, you know, we could just do our input here again then, right? We will just ask him. So email equals nothing. It's not going to end with any of those. Now, what if we wanted to check for the @ sign? Right? Email addresses should probably have an @ sign. well, you've got something for that. So one of the things you can do, now a couple options here. You can, let's say, let's go back to, no, we can just do it with email. So we entered your email, and then we'll say print the @ sign is in position, and then we'll get the value of email.find the @ sign. So find will tell you what position a letter is in here. Right, so we go back to our string documentation here, and we look at find. Find returns the lowest index in the string where the substring is found within the slice. So slicing we'll get to in a second here. Great, so we can figure out whether or not we're going to find it here. Okay, so we'll enter an email address at opencc.edu. Says, okay, it's in position 7. It's the 7th character, right? 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. Oh, that's the 8th character. Indexing in Python, like most programming languages, starts at 0. So technically, this is the 0th character, then the 1st character, 2nd, or the index of this character. It's kind of weird here. But if it's not in there, if I were to enter an email address where it doesn't exist here, like when I was typoing it here, -1, not found. So you get negative if it's not found. That's one way to see where it is. The other thing we can do is we can use an in operator. So in is really cool. You can say, okay, if it's not one of these, that's invalid, and the @ sign is not in email. We got to tab that in one, right? Is that better? Okay. So we're saying, okay, it's not ending with this, and there's not an @ sign in it here. That is invalid. So in will say, is there something inside of this string? Is this value contained in that string? So when we give this a run here, enter email, sure, opencc.edu. Doesn't find, oh, it's not a while loop here. Oops, this should be while here. Now we've got a validation loop. Exclamation.com. Did it not? Why did it not run here? Our not is happening too soon. We need to not all of that together first, then and it here. Because it was doing the anding this one together and then knotting that. We'll fix that up. Okay, one more time. We'll enter an email address. I do an exclamation mark instead. Uh-oh. Why is it not giving me the email here? It's not one of those, and exclamation mark is not in. Then it should run again. We only want not one of these here, right? Because if it does end with this, that's true. But then we should be anding this. Oh, I wonder if this one is messed up. This should be fine there. Let's try that. Nope. Oh my goodness, here. And is not in the email, should be true. Oh, this needs to be an or. That's what it is here. So if it's not one of these or not one of these here, not this. Sorry. Logic is hard sometimes. So not ending with this and this and this and this, or doesn't have an @ sign. Either one of those should make the loop keep running here. So it did end with .com, but it doesn't have the @ sign. So an @ sign, .com should be okay. And now we have an @ sign. Okay. So we can figure out if something is in here. And now this doesn't even have to be single characters, right? Which is kind of fun. So you can have this sort of in check with an entire other string if you wanted here. So if we were to ask someone what their name is, so name will be how about an input of a name? Input of enter your name. And we can say, hey, if Eric is in name.lower. We'll print, hey, my name is Eric2. So you can check for an entire string inside of something else here. It doesn't have to be a single character. So enter your name, Eric Chernesky. We can, hey, my name's Eric2, all those other things. Enter your email address, sure, we can do that. So lots of fun operations we can do with strings. Now, we can loop through strings as well. We can do this one character at a time if we wanted to. So why don't we do that up at the top? We'll say all the characters. You can say for character in name. Using the same in word here, which is funny because it's like the in operator over here. We said if it's in something, but we can use it in loops, right? For number in range, for character in name. So strings are technically collections, right? They're just a bunch of letters all put together here. So I can loop through one character at a time. I can print the character. Hector, my friend, thank you so much for donating to the Student Scholarship Fund over the University of Michigan Dearborn College of Engineering and Computer Science. So glad to have you along. So getting each character out, we'll do this one at a time here. We can loop through. Stop and run. Eric Chernesky. We'll get all the characters, including that space, because the space is a character here. Right? We see Eric Chernesky. So we can loop through one at a time. Now, the other way you can loop through is you can do it by index. Remember, so every character is in a given position. So index is like what position it's in here. So we want to say for index in range, length of the name. It's a big mouthful here, but the ranging from the length of a name, so length of a string tells you how many characters are in the string. So in Eric Chernesky, there are 14 characters, right? 4 in Eric, 9 in Chernesky, plus a space. Should be 14 characters. So range will give me 0 up to but not including 14. So I'll get 13 at the end. 0 through 13 is 14 different values here. And then to reference a single character, we would print the name, and then you use square braces here. We say index. So square braces meaning index of, essentially. So you'd kind of read this name index of the value of index. People love putting I here, meaning index, and it drives me crazy because it's not hard to type index, and I don't, just like seeing I everywhere is I don't like it. So I will almost never use the I value there. I'll just say index. It's a little bit more wordy, but that's just how I do it. So we'll get the same thing, the same result here, one character at a time. Eric Chernesky here. We'll get it with our for each character loop. Then we'll get it again using the index loop here. We'll say for getting out one index at a time. So if we wanted to, we could print out the index as well. We could say index and a colon and then the name. Probably, no, we got another space already. So this will show me what indexes all the characters are at here. So let's just do Eric, make it a little easier. So index 0 is an E, index 1 is an R, index 2 is an I, index 3 is a C. Right? We always start at 0. There's lots of reasons for this. The technical mathy reason here is when Python goes and stores a string somewhere. It's storing a bunch of characters. Now, somehow it knows how many characters are in it, but the first character is stored at that memory address. The next character is stored at the size of a character plus the starting memory address, number of bytes away. Remember, we have to store everything in bytes as in zeros and ones eventually. So we store things. The first location is the start of where that actually is in memory, and then the 10th thing out there is 10 times the size of what we're storing, plus the starting location in memory. So it's a quick way for the computer to know how to go find something with some arithmetic. Yeah, I hate I. Thanks, Professor Burp. Join the hate I group. So we can get out the name and the index here at the same time. Now we can't really do a whole lot with it here, and if we wanted to, we can't say name of index equals something else. How about like name of index dot upper? Like if we wanted to like uppercase this ourselves, we can't go change it one character at a time here. It's going to crash on us and say, hey, the string object does not support item assignment. Remember, strings are immutable. You can't change a character inside of a string. That's not allowed. a language like C++ lets you do bad things and do this, right? And we shake our head at C++ because it's probably pretty dangerous. I don't know. I have a strong aversion to C++, so we're not able to change it here. So you can get the values out one character at a time with this notation, but you can't change the values with that notation. The strings are immutable here, right? So this idea, strings are immutable, can't be changed in memory. Mutable? There we go. So what we do then, we're not changing the values. We're saying, okay, I'm going to assign it to a new string in memory. So name.lower makes a new string in memory, and then name points at the new location in memory. Right, so we tell the operating system, I need a place to store a string. It gives me a place. Sure, store it over here. When I make a new string and say name equal that new string, it says, okay, now you point over here instead. We're just changing where it's looking here, changing that location. All right, so we got some of those. Let's take a peek here. Let's see. What else are we doing here? So string, yeah, this sequence type, it's a collection. We have a bunch of values. Technically, the order matters here. I can get the length using length. Yep, we can traverse with the loop. Slicing is fun. So slicing a string will take a copy of a portion of the string here. Again, maybe not very interesting here, but if we wanted to, we could say, hey, if the space character is in name, I'll say first name is going to be, well, I need the first part of the name. I need to take a slice of it, a piece of that string, up to the space character. So I'm going to take name, and then for slicing here, you still use this square brace notation, which is a little funny. We're using this square brace notation, but I want to start at index 0, and I want to slice up to, so the starting location, colon, the ending index, not including. Slicing is fun. So taking a slice with the square brace notation is the start index, colon, end index, not including. Does that make any sense? Start index, index not including. So where do I want to stop? Well, I want to stop at name.find the space. Let's find the space character. Right, wherever that index is, remember it would tell me what index it was at here. So name find will turn into a value. Maybe we'll make that its own variable here. So this is the position for index of space is name find the space. So tell me what index it's at, and then I'll slice from 0 being the start here, up to that space, and that'll be first name. And then last name will be name sliced at the index of the space plus 1, because I don't want the space, right? I want to start 1 after the space. And then for the end character, I can say length of name if I wanted. Right? So length of name would say if Eric Chernesky's 14 characters long, would put a 14, it'll slice up to index 13 because it doesn't include that last one. And then we can print first colon first name, and then we'll print last colon last name and see how well that works for us. So that's only if there's a space in there. So if I just type in Eric, it doesn't do it, right? But if I do Eric Chernesky, zoom in a little bit, Eric Chernesky, we should get first name is Eric, last name is Chernesky. I raise that up a little bit more. Okay, because we found where the space was and we took a slice of that portion here. So same idea with our email address, right? Once we know that the email address is good here, and actually let me stop crashing here. Let's not do that. This crashes. Can't change characters inside a string. Right, so once we have a good email address, then I can print the, how about this will be, I don't know, what is it? Is that the user? What's the first part of the email address called? I think it's just called user, right? And then you have a domain, the user ID, or the ID. Sure. Is going to be a slice of email, so starting at 0, colon, and then we want to go up to the @ sign. So we'll take email, find the @ sign. And then we'll print the domain is the email sliced from email.find the @ sign, parentheses, there we go, the @ sign. Okay, we're doing this twice and I feel bad here, so let's save this here as the index of @ sign. There, it'll maybe be ever so slightly cleaner here. So we have start at the @ sign +1, going to the end, which is length of email. So we can split up their email address. So Eric here, enter your email address, charn1 at oaklandcc.edu, and we get my ID is etchrn1, the domain is oaklandcc.edu. Okay, so we split it essentially by finding it. We took a slice, we took a portion of it. Now slicing makes a copy, right? We're not actually taking that memory address here. We're going to make a copy of all those letters from here to there if we wanted. So we can slice strings. We can do some fun things with that. If you try and start and end at the same location, oh goodness, that zoomed a lot, you get nothing. Because remember, it doesn't include the end. Now the other fun thing is the start and end are actually optional. If you don't put a value in, it assumes you want to start at the beginning. If you don't put a value in for the end, it assumes you want to go to the end. So we don't really need to end at length of email here. We can just put a colon in, right? Because if there's nothing after the colon, it assumes that you want to go to the end. So with a slice, the notation, this is the start index, really assumes it's 0, and the end index assumes it is the length of the string. Right, so these are the defaults. Yeah.
So where you have a 0, colon, can't you just get rid of
Yep, we can get rid of the 0. Yep. Yeah, I actually should put that down here then. Thank you. So the other thing that means is if I wanted to, I could print email sliced from start to end. Again, this is pretty silly here because why would I want a copy of it here? But you can. This will make a whole lot more sense once we get to lists. Why you'd want to do this slicing notation, because this works with other sequence types. We just haven't got there yet. So you can do the same sort of thing here. The fun thing you can do, though, is you can also get every other character if you want. So there's an optional step sequence. So this is every 2 characters. So this is really then the start index, colon the end index, and then this is, I think they call it the stride or step. So how many characters should we go every time we move? So this will be every 2 characters here. We'll grab. So now if we look at this, we get Eric Chernesky and etchrn1 at opencc.edu. And every other character in my email address is garbage. But we got every other character for fun. So if you wanted to do encryption is the wrong word, a cipher to mix up someone's email address, I could take those values, print it out, comma, email, starting at index 1, going to, well, I want the length of the email -1, right? I want to go 1 back from the end. I guess I still want to go through the end here. So we should be fine going to the end here. Stepped by 2. We'll take both of those together here. So print Eric Chernesky, my email address. The first one is the 1st, 3rd, 5th, 7th, 9th, on and on and on, and then the rest of the letters here. The 2nd, the 4th, the 6th, the 8th, the 10th, right? 1st, 2nd, 3rd, 4th, on and on and on and on, if we wanted. So you can, this striding or stepping by certain values is fun. We could also print email sliced backwards. A negative step here will go in reverse. Eric 1 at opencc.edu. And now you get my email address back. Wow, that looks like even more gibberish here when it's backwards. Sorry, I can't zoom that up any higher. Need more like new line characters here. So you can go backwards. So this stepping can also be a negative, and you can step -2, -3, like any sort of steps negative if you wanted here, which is fun. You know, I mean, fun is I guess something. Sure. So that is our slicing here. They're immutable. We can't change them. We can loop. We can count. So if you wanted to count every letter, like count how many vowels are in my name, we could do that. So let me grab this one here. So let's actually make a function for this, because probably would be nice as a function. We'll define a vowel count function given some word. Right? We'll say for character in the word, if the character is equal to an A, and really we probably want this all lowercase, right? So if word.lower, if it equals an A, or if the character is equal to an E, right? Or the character is equal to an I, or the character is equal to a O, or the character is equal to a U, then we need a place to count this. This is our vowel count. Starts at 0. I'll take vowel count plus 1 if we found a vowel. That's right, we need our slashes here. That's fun. We went down the line. So, take our vowel count. If there's not, we don't do anything else, right? There's no big deal here. There's no else here. We'll return the vowel count. No, I shouldn't do that. This is vowels here. You don't want to use the same name as your function. That does bad things. So vowels. Return the vowels. So if I want to count how many vowels are in my name, we could do that. So let's print vowels in our name. The vowel count given the name. So Eric Chernesky, let's see. So if we counted ourselves, so E is 1, I is 1, A is 1, E is 1. That's 4. Did we get 4? Let's see. I don't remember where I printed that here. Uh-oh. Vowel's in your name is 0. Well, that's not right. Oh, we replaced them all. There were none left. Let's do that before we replace that with all the X's here. How about that?
Do we have to be case sensitive?
So I lowercased it here in my function. I said take the word and lowercase it to count the lowercase vowels to kind of make that a little easier for us here. There. Now if we count it for Eric Chernesky, we should get 4. Yep, vowels in your name is 4. Right? So again, you can go check individual characters out. It works out pretty well here. That sort of thing. Or if you wanted, there's a function for that. Right? So that's one way to do it. Or the other way to do it here is we can say my vowels is equal to word.count A plus word.count E. And again, this is probably the lowercase version of word. So we want word equals word.lower. So make sure we lowercase it first, and then we can count the lowercase values here. Plus word.count the I's. See, now it's doing the slashes for me. I don't know why it doesn't other times. I'm super confused by that. Plus word.count the O's. Nope, O's, not zeros. Slash plus, oh my goodness, word.count the U's. Right? Either of those is perfectly fine. So count will do it for you. Right? You don't need to say, hey, if it's something and loop through. Right? We can just have it count for us. Now both will get the same job done here. We should get 4 either way. This is probably a little easier for us, right? Why does it not like those are tabbed in? There, okay. I don't know. So Eric just has 2 vowels, right? And just Eric. So we get 2 vowels. So count is a fun way to do that. The in operator, right? We looked at the in operator if it can take more than just a single letter at a time, which is fun. Now, comparisons for strings are weird because technically a string can be less than another string. So with first name and last name, we'll say print first name Eric, how about first name, and then we'll print the less than character, and then the last name here, and then a colon, and then we'll print first name less than last name. We'll see which one is my first name less than my last name or not. So if there's a space, so Eric Chernesky, we get Eric is less than Chernesky is false. Well, that's kind of weird. So what happens behind the scenes is each character is actually stored as its ASCII value or Unicode value. So if you look up the Unicode table here, characters are stored as specific values. So a 65 is how the capital A is stored as a Unicode value. So people long time ago, I don't remember how long ago this was, figured out the only way to store things is in binary, right? Just bits and bytes. And when you put a bunch of bits and bytes together, you get numbers out. So we needed a way to take a number and turn it into a letter. So they built this table and said, okay, the number 65 is really the letter A. The number 97 is really a lowercase a. So when we store characters, they're stored as numeric values in the computer and then translated for us back into strings and characters. So the capital A is the lowest letter of the actual letters. Like there's other characters that are less than it, but of all the letters, the capital A is the lowest. Right? The lowercase z is the largest. If you want to say, is this thing less than this thing or this thing greater than this thing? And what Python's going to do for you is it will check letter by letter. So first letter to first letter. If they're the same, and then it'll go check the second letter to the second letter. If they're the same, it'll check the third letter to the third letter. If they're the same, it'll check the fourth letter to the fourth letter. So if I rerun this and I say my name is Eric here, I'll get false. It is not less than because they're the same. Right, it's going to compare one at a time. So let's do a greater than here for fun. We'll say, okay, are we greater than the last name? Check the greater than sign. So if we do Chernesky Eric, we'll get it is less than, yes, because the capital C is less than the capital E. The capital C is not greater than the capital E. But if we do Eric and Eric again, we get, they're both false because they're equal. So one is not less than the other because they're equal here. So you can compare strings like this. It's not super helpful to compare strings to say which one is less than the other. But this eventually will let us sort a bunch of strings together. So if I give you a bunch of names, we could sort them by saying which one is less than, right? So if I asked for a bunch of your friends' names, then I could take the minimum friend name, and that's the first friend, that sort of thing. You got some fun options with it. But just kind of keep that in your back pocket for now, that will do something here when you do less than's greater than's. Other string methods, yeah, this is that directory thing with this prompt. You can also use help. Help is kind of fun, so it will go out and get the help documentation for you. I don't know why this is so useful. Like, one at a time is not all that fun. It's like much easier to just go search for the Python documentation for that sort of thing. But it's cool that it's kind of built into Python. Right? There's a help option here built in, which is fun. Let's see. I think that's about it. Yes, we did fine. Oh, so strip will get rid of spaces, tabs, and new lines from the beginning and the end. So when people type stuff in, if they've entered extra spaces here, it can throw off some of our input checking here. So if we were to say, where do we want to do that? So the email address. So if yeah, here we go. So this ends with here. So if I were to enter an email address, so we do a name here, sure, and enter our email address, etchr1@oaklandcc.edu, and I put a space in here. It's going to ask me again because it doesn't end with one of these characters, right? It doesn't end with a .com, a .net, or .edu because there's a space at the end. And most people probably don't type spaces afterwards, but it can happen, and you don't want it to throw off our program. So what we can do then is we can take the input here, we can call strip on it to strip off all the extra white space. Move, so this is leading and trailing white space. So anything at the start and anything at the end. It'll leave all the spaces in the middle, which I don't think email addresses should have spaces, actually, now that I'm thinking about it here. Right? That's probably something it should not have, but it would leave it if it was there in the middle. So that will help remove any of that to make sure our ends with or starts with could be a little cleaner here. Those are pretty helpful. Yeah, so like if you got some long string here, you could do something with it. You could find the locations of things, get some data, do some slicing. That's the kind of stuff we did. This SP pos, I hate his variable names as much as I like Dr. Chuck. Like at pos, I look at that and I think it's a single word. Like what is an at pos? But it's the at position, the at index. I don't know. I would use other names, so that's okay. I am not Dr. Chuck, so we'll let him do his thing. All right, and then formatting. This is what I said we'd finally get to at the end. So formatting is a super cool way of building out strings. Now, this is actually the older syntax, an older way of doing things. So formatting is sort of going out of style. The better way to do this is with a formatted string. So know this exists. You'll probably see it if you ever look at existing Python code. But new Python code, we should do better things with it here. So if I wanted to format in a couple values here. So let's say if I wanted to have, I've got my name, I've got my email address, and then maybe an office number here. So let's ask for a office number is going to be an int of an input of enter your office room number here, because that'll be an integer value, right? Again, I actually have an F because it's in F building, but pretend that doesn't exist here. We'll just do integers because it makes the example better. So if I wanted to print my contact information, right, I would say, okay, here's name, I don't know, name colon, and then the name, and then maybe I would print my email address, email, and the email address, and then maybe I would print my office number and my office number. Print them all out one at a time. Now this is, long here, and then maybe I wanted to print something else. What else would I want to put here? Like, it's like if this is my email signature, I'd say like Professor of Computer Information Systems, yada yada yada. And this gets to be a little long here, but we could do this sort of thing. So Eric and chart1 at opencc.edu. And room number here is, I think, 105, I want to say. And we print out, here's my nice contact information here. Here's my name. Uh-oh. Oh, it's Eric with all the X's put in there. Oops, that's garbage here. But it prints out. So not the worst thing in the world here. But if I wanted that as a single string value, like if I needed to give this to another application or return it as a function here, so I could do something with this sort of signature to attach it places, I don't want to have to pass around a bunch of different values. I could pass around a single string. Now to do that, right, if I want to turn that into a string, so here's like my signature then, could equal, and I could do this all one at a time here. So I'm going to get rid of these prints here, get rid of these, and I would append in name, right, and I would append in a new line character, right, and then I would append in the email and a space and append in my email there, and then append a new line character, my backslashes here, and then append in, this is getting really ugly looking here, right? As I think you can see, append in my office here, and then append a new line character, backslash n, then append in this one here, sure. So now I've got a single string value for this, right? It's not the worst thing in the world. It sort of works out here, but it's pretty large, right? And not the nicest looking thing here, right? But then I could print signature, or I could pass signature to other places, or like send it to my email program, or anything we wanted here, and we still get the same values out. Right? Eric at opencc.edu 105. Uh-oh. We can't concatenate the int here, right? Because this is an integer value, so we need the string of that. Okay, sure, we'll turn that into a string. And again, anytime we're using numeric values, now it gets to be even more obnoxious here. So Eric, chart1 at opencc.edu, room number 105. Okay, we get out my signature. We're successful, but this was a little bit awkward. So the better way to do this here then, the nicer way is using a formatted string. So here's the signature here is going to equal, And now what we can do is we tell Python, hey, I want a formatted string. So you put an F in front to get a formatted string. With a formatted string, then, I can say name colon, and now we do some crazy things. So I'm going to use curly braces here and put in name. And then I can add in my new line character if we want it. Then I'm going to say, okay, let's then append email colon email. Oh, if I'm appending, I need another formatted string. Shoot, another formatted string here, plus the new line character. Right? And then we can append in here a formatted string of office number here. And then add in as well, oops, my backslash is here. I guess it doesn't look too much nicer yet, but we'll get there. We'll get there. This one doesn't even need to be formatted, right? Just append that one in. Another new line character inside of there. Okay. So now, with a formatted string, it will substitute the value of a variable in place for you. So instead of having to add in here and then do another append in here, I can just, in curly braces, put the variable in. Now, again, this is multi-line and it's kind of ugly anyway, but it's going to work out, should work out for us here. So we'll do Eric, chart1, cc.edu 105, and we still get out that same looking signature here, but I've had to type less of those plus signs here, start end quotes less often. It's really just a time saver. It's a way to substitute these values in, is more common for us. That's a formatted string. And then there's some other really cool options if you have numeric values here. Like let's write another function here for fun. So we'll do a get grade book line here. So if you give me the student name, the student, and then how about the score? I don't know, percentage score. Percentage score. We'll take all of that and we'll put that into one nice little gradebook line here so I can like print out a bunch of these values here. So I'm going to return a formatted string of the name colon the student name and then the score colon score, maybe a dash there instead of a colon. Now when you're formatting numeric values, you get lots of cool options, and I never remember which is which. So this is Python string formats decimal places. And we can specify how many decimal places we want. So if you give it colon 0.2f, will round to 2 decimal places. A plus will add in the decimal, or add in the sign for you here. No decimal places, 0.0f. Just go Google it. It's not worth remembering here. But I can say, hey, I want to format in the percentage score colon 0.2f to 2 decimal places. Or really, I probably only want 1 decimal place here as a floating point number here. So now we're going to see this formatting string can do additional things for us, like round or take certain decimal places. You can even add in specific padding here. So if we wanted Python format, this is integer leading zeros. Here we go. So if you wanted some number of leading zeros here, I don't want the zero fill. I want, where is it here? Greater than 0n? That's ugly. What is, oh, n is the length of the new string you want to create. Zeros for the zeros here. Okay, so like for our clock example here, we could format in how many zeros we want so that I always get 2-digit values here. So I'll come back to that in just 1 second. Let's just make sure we can get this format our percentage score here. So if we were to print value of get gradebook line here for Eric, and then what score do I have? How about an 89.65? Let's see which way it rounds, right? So how about 89.95 for fun here? Let's see if we can print that out. It rounds up to 90.0. Right, to 1 decimal place, it will automatically round for you. Hey, thanks so much for following along, my friend. So with the formatting here, it does round. So you need to be a little bit careful knowing that it does round. but that's nice that it does round for you most of the time, right? You don't want it to just truncate the decimal place. Usually we want things to round, but remember it'll keep on rounding, right? Which is nice. All right, so let's stop that one for a second here. I'm going to go back and open up that lab here. I'll do that in a new window. I'll keep them both open. So when we were printing these out here, if I were to print a formatted string here, I could say, hey, colon, hour, and then it was colon, what character was that? A leading character, apparently, with a 0, 2 digits. Here, so saying the leading characters, I want to put a 0 in up to 2 characters. And then I don't need to do all my extra quote signs here. Then I can do another curly brace. For minute, again, do the same thing here. Do 2-digit minute, colon. Oops, that's the wrong place for that. And then the second value with 2 digits. And then end the string. Oops, single quote. So a formatted string that will do the leading digits for me here. So, I don't know, 1, 1, 23, sure. And now we see all of those single digits get padded with the zeros here. So we said, hey, I need padding. So if it's instead of a single digit number, it would give me the 0 here. So that formatted string is super nice for that. So again, formatted strings are really the way the world is moving in Python. And the technical term for this is interpolation. It's taking a value and interpolating it inside of the string here, so you can give it variables. And then you also notice I didn't have to tell it that it was a string value, right? In my concatenation example, I had to turn it into a string. With the formatted string, it says, oh, you want this in a string, I'm going to convert it for you, and it's helpful, which is super nice. So it also saves you the time of having to convert any of your numeric values. Okay, so a lot of cool things we can do with strings. Again, there's nothing wrong with this format operator. We're sort of moving away from it, though, because it does the similar thing, but the formatted strings tend to be nicer for reading. Like, I have spotted %d camels, % camels. Perfectly fine, but with the formatted string, we can just put in curly braces, camels. And you can actually see the name of the variable in here as well, because if you want to substitute more than one thing, you had to give it in a list. And then you had to say, okay, well, the first thing goes to the first thing, the second thing goes to the second thing, the third thing goes to the third thing, and it's a big headache of like, okay, I have to mix and match, and then reading the string gets to be really awkward as well. So you can just put in the values that you want here, which is really fun. Yeah, and that is about it for strings. So I am more than a liter through my Coke now, so we're going to take another break. I'm just going to take the vote here now, and then we'll come back in 10 minutes. We'll talk about the next project and the next lab. Sound good? I know, there's lab every week. Lots of stuff. All right. Put some music back on, a few folks online, and we'll go from there. So I'll put us out to, is that 8:07? All right. See you folks in a couple minutes. get going again. Sweet. All right. So let's talk about the lab first, and then we'll do the project. Does that sound okay? Make a new repository for you here. So this is going to be lab number 5. 5, this is our word scrambler here. This will be due next week before class starts. I'll make it 10 points. 4 labs. There we go. Turn in our URL. 2131 summer lab 5. This is my Python template. All right. Sweet. Here's our link. Submit the to your repository or main file, UI file. Sure. So we're going to write a function that will allow the user to scramble a word given a couple, so given the, what do we want here? So I want to scramble the, given a step or stride. So when we looked at scrambling the email address, we did a stride of 2, right? We said, okay, let's take every other character starting at the beginning and then every other character starting at 1 here. But this should be for any given stride. So any stride up to, or I mean, even if it's longer than the, if it's as long as the word, then it just gives you the word back. It's not really scrambled at that point. So if I said, hey, scramble Eric with a stride of 4, it just won't scramble, right? Because I can't jump 4 characters, right? It won't do any of that here. But aside from that, you know, any sort of word, and really this may be a sentence given a stride here. It's probably a better way to think of it, because like a long sentence here, we can really scramble up here. So we'll take the first portion for the given stride, and the next portion for the given stride, on and on and on until we get to the length. So if I say I want to stride at 5, I need to start at 0, striding 5. And then I need to start at 1, striding 5. I need to start at 2, striding 5. I need to start at 3, striding 5. And I need to start at 4, striding 5. To get starting at 0, 1, 2, 3, and 4. Or 0, 0, 1, 2, 3, 4. Yeah, because 0, the next character will be the 5th index, would be that one. Is that a question?
Yeah, I was wondering if the stride, if it ends on a space.
That's okay. We'll just get the space.
Space?
Yep. Yeah, because space is a valid character.
Space is here.
Yeah, yeah. So if I give you a long sentence here, we can like totally scramble this thing up here. So something like, let's see, if we did Eric Chernesky with stride 4, right? So we're just going to look at this one real quick here and see. This would be a 0, 1, a 2, a 3, 4. Oh, that doesn't line up quite right. Hang on. Let me do it over here in Python. This will line up a little bit nicer here. Oh, I didn't actually commit any of this stuff either. So here's more strings. Okay, so we don't need the lab one there. I want this other one here. So if we look at the indexes here in Eric Chernesky, right? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the E is really like a 10. 10, that's getting a little ugly here. I'll space this out just so you can see it a little better here. 12, 11, 12, and 13, right? Is that, here, maybe space them all out a little bit more. So that's 0, that's 1, that's 2, that's 3, that's 4. And then another space there. Okay. Does that make sense? How we're looking at what these ones are here? So if I were to say Eric Chernesky with a stride of 4, I would start with 0. So I'm going to get an E, and then I'm going to jump 4 characters. So go from 0, jumping 4 characters, right? We'll skip 0, 1, 2, 3, and 4. Will then take me to the C. Then I'll get a C. I'll jump 4 more characters. So 1, 2, 3, 4. I get an N. Jump 4 more characters. 1, 2, 3, 4. I'll get the y. Right? So I get the first, the fifth, this is, they're numbered weirdly here, I'm sorry. Striding 4, is that right? Striding 4. 0, and then skip, that's a stride of 1, it's a stride of 2, stride of 3, stride of 4. No, I would get the space here, sorry, the space, and then I would get the stride of 1, 2, 3, 4, the R, and then 1, 2, 3, 4, and then I get the K. Okay, there we go, then I get the K. So E, R, and K, almost like Eric, that worked out nice. And then for stride, then the next section I do is starting at stride 1, so I get the R, and 1, 2, 3, 4, then I get the C, 1, 2, 3, 4, I get the N, 1, 2, 3, 4, then I get the Y. And then the next place I have to start at 2, right? Then I get the I and stride 4, 1, 2, 3, 4, I get the H, 1, 2, 3, 4, I get the E, 1, 2, 3, and we're done. I'm not going to get anything else. And then starting with the C here, right? I'll get C, and then stride 4, 1, 2, 3, 4, I'll get the A, 1, 2, 3, 4, I'll get the S. So that is Eric Chernesky split with the stride of 4, or scrambled with the stride of 4. Right? But the function should be able to handle any given stride. Right? So it's going to be a loop inside of a loop. Actually, no, just one loop, right? Just changing the stride here, like looping from stride, because we need, that's our starting position, right? So from 0 up to, but not including the stride value, will be the indexes we start with in those ranges when we slice. Right, so we take a slice, we'll start at 0, we'll take a slice starting at 1, take a slice starting at 2, take a slice starting at 3. My stride was 4, right? So those are all the starting positions here, the stride of 4. And we'll just stride through, scrambling it up there. Right? Okay, let's see. Where do we, so we could like scramble up something like signature, right? This is technically one long string here. Scrambling new lines is going to be really weird, but you can, right? It's just a character. The new line is a character itself in one big string here. So we could scramble that one if we wanted, right? When like we were scrambling some of these ones. That would be fun. Okay, so that's what we're going to practice for the lab. Just doing, let me paste all that in that we got here, right? For anyone who wasn't watching. Hey, that didn't come out too bad. So this is our, for example, our Chernesky with stride 4. Okay, so just practicing using some strings here. Can't spell example, that's okay. I scrambled the word example on purpose there. And we'll talk about the next project. So project 3. Project 3. This one is again here. Oh, I forgot to see how many points those other ones were worth. I'll go back to that in a second. So I want to make sure we're doing, the points should go up every time because you don't get to forget anything, unfortunately. So this one's due in 3 weeks then, right? Because we're not July 4th. Just pretend that week doesn't exist. So 7-11 before class starts. Let me see how many points those other ones were real quick. Is there no audio? No, I think I'm there. Okay, that was good. Sorry, I was forgetting to watch chat. Hey, Paladin, how you doing today? So let's look at these assignments here. Let me go edit this one and see how many points that was. That was 12 points, so let's go like 14 points here for this one then. So 14 points in projects. Right, we need a classroom link. Guys, 2131, summer 2022, project 3. Python template. All right. So there you go. So please submit the main.py file link and a self-assessment using the rubric. Again, score yourself. Like, make sure you're checking that rubric, seeing how your score is. Rubric. There we go. So we're going to build a hangman game. So we're going to create a hangman game in Python. Now, I know if you Google Python hangman, there are results out there. I'm not dumb. You can't just Google it and turn it in, right? That's no good. Just like in an English paper, you can't just find something and say, hey, here's my citation. Here's a direct quote, 5 pages long. No good. Okay, so to help you avoid that, I'm going to ask you to do it in a very specific manner. Does that sound okay? So you're welcome to go look at some of these things for inspiration. Right? That's okay. You can see how other people solve it here, but we're going to build it in a very specific way to help you practice some of these functions things and practice some of these string things. Is that okay? All right.
I can't remember hangman.
So that is the hidden word. You have to guess one letter at a time, and if you guess 5 times in a row, or the head, the body, 2 arms, and 2, so 6 times, 6 wrong guesses, and you have the hanging man, and you've lost. Here.
I was at clothing.
Try to make it a little easier.
So the user has to guess.
Yeah, so the game is you have to guess a hidden word, 1 letter at a time. So if you guess the correct letter, if you guess a correct letter, it is displayed instead of blanks. So it's going to show you a hidden word shown as blanks. Right? It'll display that letter. Instead of blanks. If you guess an incorrect letter, incorrect, 2 R's, 1 C. Incorrect letter. Add to the number of body parts on the hanging man. It's a really kind of gruesome game for children to play. Like, let's put a guy on the gallows. Okay, this is fun. Yay! Look, you killed him. You lose. I don't know. Kids do some weird stuff, I guess. So, so we're going to, when we do this here, so we're going to have a function for print gallows that takes an argument for number of body parts. Here. So specifically a print gallows function, and you want to print the gallows, right, with the number of body parts. So I'm not the best ASCII artist, but something like this ought to work here. So if you want to print some pipe characters here, and then like some either dashes or underscores for the platform here, and then you can do some this way, and then eventually in here you can print, like, here's the rope, and then you can print their head as a big O character. Nope, just an O. And then you could print another pipe as like a body part, and this could be an arm over here, like a slash. Maybe we'll just do a dash here for an arm here. And then an arm out that way, and then for legs, you can do dash characters. They don't line up quite as nicely here, but they sort of line up here. You want to do some dashes. Right? So here's the body, or the head, the body, the legs. They probably have a little bit longer of a body here. That's a little weird here. Again, I'm not much of an artist, but something like this for the hanging man, right? You could use. You're welcome to use this art if you'd like here as well. That's not a problem at all. But
So
it would.
we could use like print rope with head, print
Well, no, so
head with arms.
so print gallows should take the number of body parts. So at 0 body parts, we should print no guy hanging. With 1 body part, I think you start with the head, and then you add the body, and you add arms and legs. I don't really, it doesn't really matter what. For example, print gallows of 6.
We have to have 8, right?
Oh, so the head, the body, left arm, left leg, right leg, or something like that. We'll do them for you.
And then rope,
Yeah, the rope doesn't count. So like the empty gallows then would look like this. Right, just take the guy out. So there's an empty gallows here. Yeah, this would be 0, right? So this is print gallows of 0. Yep, and this one would be print gallows of 6. Yeah. So some examples, right? So we'll print the gallows, right? Whether or not, and we'll show how many hanging parts they have, right? And then, so that's our printing the gallows here. We'll have a function. Oops, let's see. include a function for print the hidden word. And this should take the hidden word as an argument and the letters guessed here. So we're going to be tracking the letters guessed as a string. So when I guess a letter, I'm going to add that letter to the letters I've guessed. Right? So I can have like A, E, I, O, U as my letters guessed all together here, and you can loop through those, right, to see what letters I've guessed, or you can say if something's in something or not here. So we've got a couple options for how we're going to do that. So if the letter has been guessed, you'll print the letter. Otherwise, so like if the word was Python, and we had guessed A, E, I, O, and U, we would print a dash, a dash, a dash, a dash, an O, probably uppercase. I don't care if it's uppercase or lowercase, and a dash for N. Right? Right, so spaces if it hasn't been guessed, and the letter if it has been guessed here.
So they're allowed to guess a string?
Well, they can guess one letter at a time.
Okay.
But we're going to keep adding to this letters guessed string because you can loop through a string really easily. Or check to see if a letter is in another string pretty easily. Okay, so print the hidden word that takes these values. Okay, and then we'll include a function ask user for guess. Now this will be given the letters guessed as well, and it will validate or ensure, use a validation loop that they can only guess a single character and it hasn't been guessed already. So I can't guess the same letter more than once, and I can't give you something where the length is more than one. Right? We can get the length of a string out. Make sure they don't give you more than one letter. Right? Because that would do some bad things to how we count our games and our guesses, because we're tracking letters guessed here. Right? So if I guessed the entire alphabet, all of a sudden I'm now going to have the hidden word. Right? Okay. So that's our function ask the user for guess. We'll include the function print the hidden word, and then we'll include that function for print gallows, and we'll include a function is game over, given the hidden word, given the letters guessed, and the number of guesses. Okay, the game ends after. Actually, no, that's not. This is number of incorrect guesses. After 6 incorrect guesses, or once all the letters in the hidden word have been guessed. Right? Either way, the game is over, whether or not you lose or you win. Right? So a couple ways that we're breaking this down. Right? We're taking a big problem and doing that functional decomposition, which 4th of July parties are coming up. There's a chance for you to use that word at the family party. Just the look on people's faces when you say it is really funny. I don't know. Everyone knows I'm a nerd and I do dumb things or nerd things all the time, but that's okay. So either one of those will end the game, right? If our game is over. So here's what the hidden word is. Here's the number of the letters that have been guessed. Here's the number of incorrect guesses. Either of those will end the game. Okay, our function asks the user for the guess, that validates, make sure they haven't guessed it before, and they give us a single letter, print the hidden word, and then let's make it. I haven't lists yet.
Just use a dictionary for go out to the web and find some words.
Yeah, I'm gonna give you some random words here in a second. So here's the 1,000 most common words. Let's see. And here we go. 1,000 words. So give me a second here. I will turn this into a list you can get real quick. And give you a new scratch. 1 sec. Python. All right, awesome. I'll give you a way to get it here. Why? Okay. Yeah, I'll show you how you can pick a random one out in a second. Let me make sure this is a decent list here. Import n. I think we got a funny thing here. Raise. Okay, that's fine. Okay, we're almost there. Just cleaning up the list real quick. Refuse as a verb? Why are they telling me if these are verbs or adjectives? Check noun. Accept. Okay. Is that a repeat? Do we already have accept? Maybe not? I don't know. Increase. My goodness, that's a lot of words. The 3-letter words are really hard to guess too. This is kind of mean. We should do like Wordle words. Should we do the Wordle words for fun? You always have to guess a 5-letter word. Oops. This is fine. Okay. I think we got all of them here now. Oh, almost. I don't want it. I don't want in. I don't want if. Those 2-letter words are no fun. All right. Okay. And then let me do a replace here real quick. Edit. Place. Replace with regular expressions. Add in a quote. Place all that. $sign, comma. And at the end, $sign. There. Nope, replace all. I think that ought to do it here. And then we'll throw this into some Python code. All right, come back here. Here's my word list. It's going to equal that. Let's see if that's fair. It's real long here, but that's okay. Where's my scroll bar? I don't get a horizontal scroll bar. I think that's fine. Let's see if we can print the word list real quick. All right, cool. So print it out okay. So to get a random letter then, or a random word from the word list. Again, don't worry too much about it. We'll talk about lists later, but I can get a random word is equal to my word list, index of random.randint, randint, 0 to length of the word list, -1. We got to import random. And if we're to print the random word, it should give me a random word out of that word list. Yeah, so there's fresh, and then next time, second, and then plenty, and then late, and then distance, and sky, and bus, and on and on and on and on. So we should be able to get random letters with this. So I'm just going to link to that here. So this is random word. Push that. So that was in week 6 for a random word. So you get pick a random word with that, and then have them guess it. Right. So show the hidden word 1 letter at a time. If you guess the correct letter, displays that letter instead of the blanks. If you guess an incorrect letter, add to the body parts. We'll have some specific functions. Right, and then all of this. Have the entire game in a loop that allows the user to play again. And once the game is done, if they want to. So like you'll have to ask them, hey, do you want to play again? Yes or no? And if they answer yes, keep on going. Do it again, 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 do it again. Okay? That make sense? All right, so that's the Hangman game. Again, I know there's solutions out there. Like that portion of it is not that most interesting part. You have everything you need. You shouldn't need to go look up anything up, but again, kind of follow along, build it out with these functions, one small step at a time. Will make life a little easier for you as you go. And that's our Hangman game. All right, questions, thoughts, concerns? We're doing okay? All right, awesome. All right, folks online, if you got anything, just send me a message on Discord or text me, send me an email. I got it on my phone. Yep, time for quesadillas. Oh, I'm jealous now. I'm jealous. I had a salad for dinner. This diet thing is stupid. But, I'm a little overweight, so it's probably good for my health if I'd like to live a little longer. We'll see. It's a trade off. All right, folks, you take care. I'll see you around.